Yeah.
Okay, good evening, everyone. Sorry, I was having some technical fault here. So, but we can begin class. Okay, so as indicated, today we begin looking at integration. We've looked at differentiation, so we know what differentiation is. So today we start integration. Start integration. Yes. So I'm saying we've done differentiation. We know what differentiation is. So that's what we need to know about integration. Integration is simply the reverse of what we've been doing, which is differentiation. So we're going to see. So you need to recall that given that if this one, dx of this function f of x, this one is equal to f prime of x. So then that's what you get. You get f prime of x when you differentiate. So we seek to find a way. If we have this one here, the f prime of x, we find a way of getting back to this function here. That is what you're calling differentiation, integration. So so if, in general, so if we have, say your f prime of x is equal to something like this, say n, then you have your x to the power n minus 1. Recall, so you're going to denote integration as with this sign, which is an elongated s, like that. So we need to find the integral of this. So given this one, x to the power n minus 1, then dx. So you have that if f prime of x is equal to that one, then dx, then you need to get some function f of x, which you have like that. And then that's how can you obtain that? This one you obtain it, say, which is equal to this one here, n over n minus 1, then plus 1, then x to the power n minus 1, you add the 1 there, then plus some constant c, because we are adding this constant c because say we have, can give an example. If you have, say, you find the integral of 2x, so you're going to notice that this one will give you x squared, but we don't know, maybe this f of x at some constant, say it can be plus 2, it can be x squared minus 4. All these answers are correct, but we are not so sure which one was the constant. So that is why we use a c to represent that any constant. So you say this one is equal to x squared plus c, where c is any constant. So that's what we have. So this is the general form we're going to use when integrating. So that's what we have. And this one is what we're calling, say, the general answer. So that is the general answer to this expression here, the integral of 2x dx. So similarly, so again, if you have, say, the integral of this one, the f prime of x dx being equal to f of x plus c. So this is no different from what we are from saying here. So we see the f of x, that function, then plus the c, the constant. That's what you have. And then I want us to talk about this. So if we have, say, dy dx being equal to f of x, so we have dy dx inside this open interval. It is differentiable in this interval from a to b, not inclusive, a and b not inclusive. Then we have that we can have this function with a capital F of x being equal to the integral of f of x dx. So this one is called the indefinite integral. This is the indefinite integral. So that's what we have. So that is called the indefinite integral if you are differentiating this, integrating this function in an open interval where x is between a and b. Okay, so I want us to look at some fundamental integration formula. So you can keep this in mind. So the fundamental integration formula so we know how to differentiate this one. So remember here, when you have, say, the integral of x to the power n dx, then this is simply equal to this one, the 1 over n plus 1, then by x to the power n plus 1, then plus a constant c. So that's what you're going to have. So the first one, so these are important, make sure you write them down. So if for one, we have if k, so if k is any constant, if k is any constant, then we have the integral of k dx as simply kx plus c. This is kx plus c. Then 2, we have if this one, this is what I'm just from writing there, dx, this is equal to 1 over n plus 1, then x to the power n plus 1, then plus c. So 3, the integral of, say, 1 over x dx is equal to ln of x plus c. It's unfortunate we never looked at how to differentiate the ln of x, so that is where we actually get this one from. So we simply observe to say the differentiation of ln say x is simply equal to 1 over x. So when you integrate, you simply get back to this ln x. So that's what we have there. Then also for you have something like 1 over say x plus some constant dx. This one is equal to the ln of x plus k, then plus a constant. Then we can have our fifth formula here. If we have k, then f of x dx, then this is simply equal to k. Then you integrate the f of x dx, where k is a constant. Then you can also look at this one, the 60th one. If you have the integral of f of x plus or minus some function say g of x, this one is equal to, then this one is equal to the integral of this one, the f of x dx, then plus or minus the integral of g of x dx. So those are the some of the fundamental integration formulae that we're going to use throughout integration. Of course, we are going to look at various ways in which you can integrate a function. So let us look at examples.
Hello.
Yes, is that a question?
Sir, just a minute.
Okay. But you have. So we're just doing this for the sake of learning. I forwarded these, everything that you are looking at, I forwarded them to you in the PDF I shared yesterday.
Okay, thank you.
Yes, so it's all there. So let us look at some examples. So let us look at an example. So you can look at example 1. Evaluate this one here, the cube root of x squared dx. So we need to find the integral of the cube root of x squared. Okay, so guys, this one is equal to, you can rewrite this one as x squared to the power 1 over 3 dx, which is equal to which is equal to the integral of x to the power 2 over 3 dx. So we see this one, we can use fundamental integration formula number 2 to evaluate this one, which will give you 1 over this one, 2 over 3 plus 1, then x to the power 2 over 3 plus 1, then plus a constant c. Then you're going to have this one. What is this one? You're going to get 5 over 3. You have 1 over 5 over 3, then x to the power 5 over 3 plus constant c, and this is equal to 3 over 5 x to the power 5 over 3 plus c. So that's what we have in there.
It's very clear, sir.
Huh? Yes, so let's move on. So you have example 2. Hello, is that a question or can't get you?
So
So
I'm
for
asking
2,
for
we
the
have
previous page.
the previous page. Okay.
Yes, where you are writing the fundamental. Thank you.
Okay, so I was saying you have these in the PDF I forwarded to you, unless you're saying you didn't receive it. Yes.
No, I didn't receive it.
No, okay, I'm going to forward it again. Can we move on? Okay, I'm going to forward this. I'm going to forward you the PDF. So we continue with the examples. I'll forward it. So we can look at example 2. So example 2 is find the integral of, there's this one 3 minus 2x. Then this one squared dx. Right, guys. Okay, so we are going to look at a bit of some fancy ways in which we can deal with this straight away. But today we are going to expand this. So we first expand this one here. So this one is equal to the integral of 3 minus 2x by 3 minus 2x dx, which is equal to, so we're going to have 3 times 3, you're going to have 9. 3 times that, you're going to have minus 6x. This times this, you have minus 6x. Then this times this, you have plus 4x squared dx, which is equal to, you have 4x squared, then minus 12x here, minus 12x, then you have plus 9 dx, and then you integrate that. And you can use your formula number 6, it's this, you have f of x, and f of x, so you can treat that as that. So this one is going to be equal to, this one is then 4 over 2 plus 1, then x to the power 2 plus 1, minus 12 over, the power here is 1, 1 plus 1, x 1 plus 1, then plus 9. Mind you, the power of x here is 0. So when you add 0 plus 1, you simply get x. So you get x there. Then plus some constant c. So this one is equal to, you have 4 over 3 x to the power 3. Then you have minus 12 over 2 x to the power 2. Then plus 9x plus constant c. So you're going to get 4 over 3 x to the power 3. Then this one can go into there 6 times 6x squared plus 9x plus c as your final answer. So you can have example number 3. So example number 3, we need to evaluate this. The integral of x squared minus 4 over x minus 2 dx. So guys, it's all about analyzing what you've been given. So you see, you can see this one, you have a difference of 2 squares in the numerator there. So you can factorize this as follows. So this one is equal to the integral of, this is a difference of 2 squares, which can be written as x minus 2 and x plus 2. Then over x minus 2, then you have dx. So this one, we're going to have the integral of, you see the x minus 2 will go into that x minus 2 to give you a 1, then you remain with this one here, x plus 2 dx. So this one is going to give you, so you see the coefficient there is 1 over 1 plus 1 x to the power 1 plus 1. This is a constant plus 2x, then plus a constant c, which is equal to 1 over, this is a 2, then you have x squared plus 2x plus c as your final answer. So for 4, let's look at example 4. Example 4, we have the integral of x to the power 3 minus 2 over the square root of x dx. Guys, you can do some algebra here. This one is going to be that one, x to the power 3 minus 2, then over, this one is x to the power 1 over 2 dx. This one is equal to the integral of x to the power 3. I'll be going step by step. I don't want anyone to miss a step, so that you'll be skipping the unnecessary steps when you're doing the questions. So I'll be going step by step. Then over x to the power 1 over 2, then minus 2 over x to the power 1 over 2 dx. So this is equal to, we're having the integral of, you know, when you're dividing the same bases, you know what happens to the power, it will become x 3 minus 1 over 2. Then here, when you push the x to the half to the numerator, it will be x to the power minus 1 over 2 dx. So this is equal to, this one is 6 minus 1, you get x to the power 7 over 2. Means 6 minus 1, you get 5. Here, 5 over 2, then minus 2, x to the power minus 1 over 2 dx. And then you can integrate here from here. You're going to have, this one is 1 over 5 over 2 plus 1 to the power times x to the power 5 over 2 plus 1, then minus 2 over minus 1 over 2 plus 1, then x to the power minus 1 over 2 plus 1, then plus some constant c. So this one is equal to, so that this is in the numerator, you're going to get a 7 over 2. So it should be 2 over 7, then x to the power 7 over 2. Then this one here, it's to be minus half plus 1, you get half. So here you get minus 4 x to the power 1 over 2. Then plus the constant c as your final answer there.
Excuse me, sir.
Yes.
I'm kind of confused. Should on step 3, there where you subtracted the 3 minus half. Why there? So
Yeah.
you said since they have the common denominator, then you just subtract the verses. Then
The powers.
yeah. Was
Okay,
it
so yeah, so
was it not supposed to be like 3 minus 2, not 3 minus half?
no, we are okay. This is okay. So when you have, remember our indices, when you have say a to the power, okay, say x to the power a, then over x to the power b. So this is equal to a, I mean x to the power a divided by x to the power b. So the bases are common here. So this is equal to x to the power a minus b.
Yeah.
Yes.
Uh,
So this is what you've done here. So this is 3, x to the power 3 minus this one here, 1 over 2. Are we still confused? So here the bases are the same. You have x and x. So they're common. So you simply subtract the powers because
okay, I get it now.
you see x. Oh yeah. Oh, okay. Okay. Thank you. Right. So we can move on. We can move on. We can move on. So let us look at another example. Okay. That was example 4. So this one is going to be example 5. Where we have x minus 4 over the root of x minus 2 dx. So what are we going to have there? So guys, here we have, okay, we have to make this expression as easy as possible. So what are you going to do? So x minus 4, you can see a difference of 2 squares there. So you can make, say, this one is a difference of 2 squares. You can write it as, if you divide, say, this one by, x squared, and then when you find the square root of x squared, you get x. Is it? So here, when you want to find the square of this one, you simply find the square root. So this one is equal to the square root of x minus 2. And then you can have the square root of x plus 2 over the square root of x minus 2. You have dx there. So you see, this one and that one will go. You remain with this one, which will be the square root of x plus 2 dx. So this will be equal to, this one is x to the power 1 over 2 plus 2 dx. This will be equal to 1 over 2 plus 1, x to the power 1 over 2 plus 1. Then plus this one, you introduce the x there. You have plus c, a constant there. So this one is equal to 1 over, this one is so this one is 3 over 2, x to the power 3 over 2, and plus 2x, then plus c. So this one is equal to 2 over 3 x to the power 3 over 2 plus 2x plus c. That's what you have. So that is so we want us to get a clear picture of how to differentiate this before we look at some complicated integrals. So you need to understand this, because this is what you'll be doing in everything, all the integration that you're going to do. You'll be doing this. Oh, thank you. Right. So this is what we'll be going to do in all the integration that you're going to have. So pay attention to this, and your integration will become very, very easy. Okay, so we can do this one so we can try this one, which will be example 6. We can try x squared plus 3x, x squared plus 3x, then minus 4 over x minus 2 dx. So you can try this one as our work. Try it on your own. Try by all means not to look at what the procedures in the PDF that I sent to you, but just try to use what we've done here and see what you'll get here. Right. So today I want us to look at another principle, the definite integral. So what we've been doing, these are indefinite integrals, but we're going to look at the definite integral now. So let's look at the definite integral. So you can have a definition. So you can have a definition. So you have, if f of x, the integral of f of x dx is equal to this one with a capital F, which is the integrated function, plus some constant c.